Today's lesson is going to be on the cosine law. So remember, with sine law and cosine law, we use these when we don't have a right angle triangle. If we have a right angle triangle, then we just use SOHCAHTOA. All right, so another thing to keep in mind is that our triangle, the end points or the vertices are going to be labeled in capital letters, which means that our opposite sides will get the same letter but in lowercase. So there's B and then lowercase b, C and lowercase c, A and lowercase a. So we're going to write out cosine law. So first we're going to have a squared is equal to b squared plus c squared minus 2 bc times cos of a. We also can write it in the form that b squared is equal to a squared plus c squared minus 2ac times cos of b. And I'm sure you can see the pattern now. C squared is a squared plus b squared minus 2ab cos of c. So notice that the angle that we want, or the angle used, will have the side in the front. So that's just another pattern for you to notice. Okay, so here, determine the value of x. So cosine law gives us the square of what we're looking for. So it's going to give us x squared. So we're going to have x squared is equal to 42 squared plus 53 squared minus 2 times 42 times 53 times cos of 115. Again, this is giving us the x squared, and we actually need x by itself. So something we can do is, instead of writing it out as x squared, all we do is write it out with the square root, and then now we have x. And your calculator should be able to digest all of that. So you're going to put in square root and then enter everything else. (53) cos of 115. And that gives us our answer. And so because everything was in whole numbers, we will keep this as whole numbers. So this gives us 80. So x is 80. And that, using that square root sign, means that I don't have to have the exponent 2 up there. Okay, so even though the law is written out with the square root, with the squares, but when we're solving for a length, we don't really want the square of the length. We just want the length itself, and our calculators can just give that to us right away. Okay, so in this scenario, instead of solving for the missing side, we are now going to solve for a missing angle. So we've labeled our angle theta. Remember, this Greek letter here is theta. Okay, so because we want this angle, we're going to start with the opposite side, and that's important to kind of remember the way cosine law works. So we're going to say 23 squared is equal to 17 squared plus 19 squared minus 2 times 17 times 19 times cos of theta. Now we're going to need to we want cos theta by itself. So let's put a little box around this. This is what we want to have by itself. So we're going to have to start getting rid of whatever is in its way. So notice I'm not working these values out in my calculator yet because I don't need to. I'm going to save my calculator work for right at the end. So we have subtracted. Remember, the 17 squared and 19 squared were being added, so we had to subtract them. And now this -2 times 17 times 19 times cos theta. So all of that is being multiplied. So in order to isolate, we have to divide. And remember, you're dividing by a negative, so you need to have that negative there. And we're still not done yet because we need theta, not cos of theta. Now, remember, cos is a function. It's not a number. So this is not cos times theta. This is cos of theta. So in order to get theta by itself, we're going to need to take inverse cos of this value. So we can just put now this big long entry into your calculator. So you can go inverse cos, open your bracket, have your fraction line, and then just type everything into your numerator. And then go down and put everything in to your denominator. And angles, generally we always go just to the nearest angle. So that's going to give us 79 degrees. Okay, so this problem is different in that we're not giving you the diagram. So part of what you'd need to do in your solution is you would need to draw out the diagram that goes with it. So here, we know we're going to have a triangle. So it doesn't matter how your triangle looks. You're just going to draw it anyhow onto your page. And it doesn't matter where you put your labels. You can put them anywhere. Just make sure you use the right letters. So they use DEF. So I'm going that way with my DEF. Now is where it matters, because now your side D of 34 has to be opposite wherever you put your angle D. Okay, so because I put angle D here, I have to put 34 over there. Okay, and then side F has to be opposite angle F, so that is where my 42 has to go. And they've told me that angle E is 24, so 24 degrees, and they want length E, which is going to be over here. So we're going to apply cosine law. And that's going to give us E is equal to, so remember, cosine law is going to give me E squared. So we'll write it out this way, and then I will just get rid of that square by putting in a square root. Times 34 times cos of 24. So remember, this is giving us E squared, and we don't want E squared. We want E by itself. So all we're going to do is type in that square root sign in our calculators, which then allows us to have E by itself. Okay, so we're going to put all of that into our calculator now. And this will give us 17.6. So if we're going to write this to the nearest whole number, we're going to have this as 18. Okay. Here's another word problem where you are going to need to have another diagram. So a ship is 250 kilometers away from its destination. To avoid a storm, the captain changes the ship's course by 24 degrees away from its destination for 178 kilometers. The captain will then turn back towards the original destination. So this, if we decide that we're going to start here, so let's just say this is our ship. Oops. So here is our ship. So let's put S for the ship. and the ship is 250 kilometers away from its destination. Okay. And what the captain has to do is he has to change the direction by 24 degrees. It doesn't matter what it looks like to scale. So that means that this angle here, he's changed that direction by 24 degrees. Okay. And then he travels that destination or that route for 178 kilometers. At which point, after that 178, the captain's going to head now back towards that destination. So what we want to know is, what is that distance that they have to travel? So how far is he now, or how far is the ship now? So we're going to just label this using our vertices. So this is going to be S, this would be D, and that would be P, using the letters that I used. If you were doing this for yourself, you could use any letters that you wanted, okay? So we're looking for the distance of S. So remember, cosine law gives us S squared. Minus 2 times 250 times 178 cosine of 24. But remember, we don't want S, we don't want S squared. We want S by itself. So we are going to use our calculators so that we can just type it in with the square root sign and no longer have S squared. So we're going to put all of that in, open up your square root, and then put everything in there. Make sure you have your brackets where they need to go. Cosine of 24. So S is going to equal 113 kilometers. And this was a word problem, so you're going to give word answers. You're going to say, therefore, the ship is 113 kilometers away from its destination. And that's it. That is cosine law.